Did you know that everything we can see in the universe, stars, planets, galaxies, makes up only a tiny part of its total mass? What about the rest? Welcome to Dar Space. Most of the universe is invisible and unknown. A mystery that has puzzled scientists for years. This mysterious stuff is called dark matter. But what is it really? It doesn't give off, absorb, or reflect light, which makes it super hard to find. But it's definitely there. So, how do we know it's there? The answer lies in gravity. Gravity is the force that holds the universe together. It's what makes planets go around stars and stars clumped together in galaxies. But when astronomers studied how galaxies move, they found something surprising. Galaxies were spinning way faster than they should be, based on the visible matter alone. This difference suggested there must be some kind of invisible matter providing the extra gravity to hold these fast-spinning galaxies together. This mysterious stuff was called dark matter. But how does it affect the entire universe? Its existence is further confirmed by how it affects the cosmic microwave background radiation, the afterglow of the Big Bang. Dark matter is one of the biggest puzzles in modern cosmology, and studying it could totally change how we understand the universe. Join us on this journey to uncover the secrets of dark matter and discover how it shapes the cosmos. Let's travel back in time to the 1930s. The first clues about dark matter emerged back then, forever changing our understanding of the universe. It all started with the work of the bold and visionary astronomer Fritz Zwicky. Zwicky was studying the Coma Cluster, a massive collection of galaxies that looked like something out of a science fiction movie. A true cosmic spectacle. He noticed something amazing. The galaxies were moving much faster than expected based on their visible mass. What an intriguing mystery. Zwicky proposed the existence of dark matter to explain this huge discrepancy. How bold and revolutionary. At first his ideas were met with skepticism, but Zwicky didn't give up and kept going with his theory. Decades later, the brilliant and persistent astronomer Vera Rubin entered the scene with even stronger evidence. Her groundbreaking observations of galaxy rotation curves were revolutionary and changed the course of astronomy. Rubin discovered something fascinating. Stars and spiral galaxies orbit the galactic center at the same speed, regardless of their distance from the center. Incredible and baffling. This contradicted the predictions of Newtonian physics, which suggested that stars farther away should orbit more slowly. What a surprise for the scientific community. The only way to reconcile the observations with the theory was to invoke the presence of a large amount of invisible matter. Dark matter, a concept that continues to fascinate scientists today. Dark matter doesn't interact with light, which makes it invisible to telescopes. But how do we know it's there? Astronomers can figure out its presence and distribution through its gravitational effects on visible matter and light itself. It's like a cosmic detective. One of the most telling clues is the rotation of galaxies. As mentioned earlier, galaxies spin faster than they should if they were made up of only visible matter. It's a fascinating mystery. This faster rotation suggests the presence of a dark matter halo surrounding the galaxy, providing the extra gravity to hold everything together. It's like invisible glue. Another fascinating technique is the use of gravitational lensing. This phenomenon happens when the gravity of a massive object like a cluster of galaxies bends and distorts the light from objects behind it. It's like a cosmic magic trick. By analyzing the distorted images, astronomers can map the distribution of mass in the cluster, including the invisible dark matter. That's how we unravel the secrets of the universe. Despite its gravitational influence, the exact nature of dark matter remains one of the biggest mysteries in modern astrophysics. What is this mysterious stuff actually made of? Scientists have proposed several candidates for dark matter particles, each with its own unique properties and theoretical framework. Let's explore some of the most interesting ones. One of the most popular candidates is weakly interacting massive particles, or WIMPs. These hypothetical particles could be the key to unlocking the mystery. WIMPs are hypothetical particles that interact very weakly with ordinary matter, making them extremely difficult to detect. However, their detection could revolutionize our understanding of the universe. Another fascinating candidate is axions, hypothetical particles that are much lighter than WIMPs, and could solve some outstanding problems in particle physics. Could axions be the answer we've been looking for? Other possibilities include sterile neutrinos, super WIMPs, and even more exotic forms of matter. Each of these options opens new doors to research and discovery. The search for dark matter particles is ongoing, with experiments conducted in underground laboratories and using particle accelerators to try to directly detect these elusive particles. The race to discover dark matter continues, and each day brings us a little closer to unraveling the secrets of the cosmos. Section 5. The cosmic web of dark matter shaping the universe we see. Dark matter plays a crucial role in the formation and evolution of the large-scale structure of the universe. Without it, the cosmos would be a very different place. In the early universe, the gravity of dark matter acted like a seed, attracting matter and forming dense clumps. These clumps were the foundations of galaxies. Over time, these clumps grew and connected, forming the cosmic web of galaxies and galaxy clusters that we observe today. It's like a vast cosmic spiderweb. The cosmic web is a vast network of filaments and voids, with galaxies concentrated along the filaments and vast empty spaces between them. It's an impressive and complex structure. The gravity of dark matter governs the distribution of matter on these cosmic scales, shaping the structure of the universe and influencing the formation and evolution of galaxies. Without it, we wouldn't have the cosmic wonders we see today. Understanding the properties and distribution of dark matter is essential for unraveling the history, evolution, and ultimate fate of the universe. It's the mystery that drives us to explore beyond the known. Section 6. Gravitational lensing, a cosmic magnifying glass. Gravitational lensing, a fascinating consequence of Einstein's general theory of relativity, acts like a powerful tool for unraveling the mysteries of dark matter. When light from a distant object passes through a massive object like a cluster of galaxies, the gravity of the intervening mass bends the light's path, creating a natural lensing effect. This bending of light can create multiple images of the distant object, similar to how a magnifying glass can create multiple images of an object behind it, revealing hidden details of the cosmos. By analyzing the distorted images and their positions, astronomers can map the distribution of mass in the lensing object, including both visible matter and the enigmatic dark matter. Gravitational lensing studies have provided some of the most compelling evidence for the existence of dark matter and its crucial role in shaping the structure of the universe, opening new windows to cosmic knowledge. Section 7. The bullet cluster, rock-solid proof of dark matter. Some of the most amazing and convincing proof of dark matter comes from looking at the bullet cluster. It's a fascinating system of two galaxy clusters smashing into each other. The bullet cluster is made up of two galaxy clusters that have passed right through each other. It makes for an awesome cosmic show. During the collision, the hot gas from the clusters, which makes up most of their visible mass, crashed together hard and slowed down, leaving a bright trail of gas. But when scientists looked at the bullet cluster using gravitational lensing, they found a puzzling mystery. Most of the system's mass isn't where the hot gas is. Instead, the mass is off to the sides. This shows there's a lot of invisible stuff, dark matter, that went right through the collision without being affected, like a cosmic ghost. The bullet cluster gives us strong proof that dark matter exists as something separate from regular matter. This shows us that dark matter barely interacts with itself or with normal matter, except through gravity. It reveals a universe that's way more mysterious and complex than we ever thought. Section 8. Dark matter and the fate of the universe. The amount of dark matter in the universe has big implications for its fate. This mysterious stuff, which doesn't give off or absorb light, makes up about 27% of the universe. The universe is expanding, but the gravity of all the stuff in it is pulling it back together. Dark matter plays a key role in this process. Whether the universe keeps expanding forever or eventually collapses depends on the balance between these two forces. This balance is delicate and fascinating. If the density of matter in the universe, including dark matter, is above a certain critical value, then gravity will eventually win, and the universe will collapse into a big crunch. A dramatic and catastrophic end. However, if the density is below this critical value, the universe will expand forever, becoming colder and darker over time. A lonely and icy fate. Current measurements suggest that the universe's density is close to the critical value, making the fate of the universe uncertain. We're at a crucial point of discovery. Understanding the nature and distribution of dark matter is crucial to figuring out the ultimate fate of the universe. Science continues its quest to unravel this cosmic puzzle. Section 9. The ongoing search. Unraveling the mysteries of dark matter. The search for dark matter is one of the most exciting and challenging frontiers of modern astrophysics. This mysterious substance, which doesn't give off or absorb light, makes up about 27% of the universe. Scientists are following several lines of inquiry to unravel its mysteries, from direct detection experiments to large-scale studies of the universe. These studies are looking for dark matter particles and trying to understand how they interact with visible matter. New telescopes and instruments are being developed to study the distribution and properties of dark matter in greater detail. These technological advances allow us to observe the cosmos with unprecedented accuracy. Theoretical physicists are working on new models and theories to explain the nature of dark matter and its place in the universe. These theories could revolutionize our understanding of fundamental physics. The quest to understand dark matter is a journey into the unknown. And every new discovery brings us closer to understanding the fundamental components of our universe and the forces that govern its evolution. Dark matter could be the key to unlocking the deepest secrets of the cosmos, and its study pushes us to explore beyond the known limits. Every step in this search takes us closer to a new era of scientific discovery, and reminds us that the universe still holds many secrets to be revealed. Don't miss our next video where we'll explore the mysteries of black holes and wormholes. What other topics would you like us to talk about? Let us know in the comments. From Darspace. See you next time.